Okay, so we're going to go over 3.1, which is polynomial functions, which are functions that are not necessarily quadratic. They can be higher order, so they're not one of the parent functions that we've already gone over. Okay, so here's our step to graphing a polynomial equation. Okay, first of all, we determine the end behavior, and we can do this by using the leading coefficient test and the degree of the entire polynomial. Then we identify the zeros by factoring or using the quadratic formula or whatever our method is. Okay, when we identify our zeros, that's basically finding the x-intercepts. Okay, then we determine whether or not the graph touches or crosses at each of those x-intercepts, and then we determine what's happening between those points. If the graph is above the x-axis, if the graph is below the x-axis, we find our y-intercept, and then we sketch the general shape. Now, I'm saying sketch because some of these turn out really ugly. So I'm really just looking for, do you have the correct x-intercepts? Do you have the correct end behavior? And then are the pieces of your graph graphed the way they're supposed to be? In other words, are they above the x-axis or below the x-axis? Okay, so it doesn't have to be perfect, but it needs to mimic the general shape. Okay, so these are all the steps we have to go through. So one by one, I'm just going to go through how to do these separate steps, and then we'll do some examples of putting it all together. Okay, so the first thing we have to be aware of is how to determine the end behavior. So we have this little table to help us. Okay, so if we're given any polynomial function, here they're calling it f of x, okay, and they write it in this horrible notation, which basically our a sub n's are just our coefficients. So this is just saying we have an x to the nth degree polynomial, okay, where all the little a's are just the number part of each term. So this is how we determine the shape of our polynomial function. If our degree is even, meaning if we have something like x to the 8th plus blah 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 stuff, or if we have x to the 4th minus x cubed blah blah blah, we don't care. Whatever this highest degree is, whatever the highest number is, if it's even, then it looks like this first row where either both of our ends go up or both of our ends go down. So basically, if it's even, the ends go the same direction. Okay, so for even, I'm just going to write over here, ends same direction. Okay, now if it's odd, meaning that the highest power of our x term is an odd number, so for odd I'm saying something like x to the 7th, x to the 51st, x cubed. Okay, if our highest power of x is odd, then it's going to look like one of these graphs. Notice the ends are going opposite directions. So I'm going to go ahead and say ends go opposite. Okay, they go opposite one another. So to determine which way the ends go, notice if they're even, both ends either go up or down. If they're odd, the ends alternate. But to determine which way it starts, we always look at the leading coefficient. Notice here, this is our leading coefficient, which for our leading coefficient, it's just the number part of our highest degree term. If that number is positive, okay, that's this column, excuse me, this column. It says a sub n is greater than 0. So if our leading coefficient is positive, then the right side goes up. Right end up. Okay. Notice here, if our a sub n is less than 0, or our leading coefficient is negative, then notice on both of these graphs, whether it's odd or even, the right side's going down. So I'm just going to say right end down. Okay, so the degree of the polynomial tells us what direction the ends are going, if they're going the same or if they're going opposite. And then the leading coefficient tells us what the right side is doing. If the leading coefficient is positive, the right end's going down. If the leading coefficient is negative, then the right end's going down. I said that backwards, didn't I? If the leading coefficient is positive, the right side's going up. If the leading coefficient is negative, the right end's going down. Okay? So on these few examples, All I want to do is determine by looking at the degree and the leading coefficient what the general shape of this graph is. And notice on my pictures up here in this chart, there's a squiggly line in the middle. That's because we have no idea what this whole graph looks like. This is only telling us the end behavior. Okay, so this first one, P of x, I look at the degree. Notice the degree of this one is my highest power of x, which in this case is 2. So it is an even degree. So if it's even, that means the ends are the same. They either both go up or they both go down. Okay, so then I look at my leading coefficient, which in this case is 4. Since my leading coefficient is positive, that tells me that the right side goes up. Okay, and I don't know, it's just always the right side. I guess you could remember it by the left side, but I just remember if it's positive, right end up, if it's negative, right end down. So since this is a positive leading coefficient, then the right end goes up. Okay, so if I wanted to sketch a general shape of this, the ends go the same. So that means if the right side goes up, then the left side goes up. Okay, we don't really know what's going on in the middle. Same thing with this next one. Identify the degree, which in this case is a 7. It's degree 7, which is odd, which means that the ends are opposite. Okay, and then I look at my leading coefficient, which here is a -1. Since it's negative, that tells me that the right side goes down. Okay, so if the right end goes down like this and the ends are opposite, I know the left side goes up, and I don't really know what's happening in between. Okay, same thing with the g of x. I look at my highest degree, which here is 4. It's a degree 4, which means that the ends go the same direction. Okay, and then I look at my leading coefficient, which in this case is 3. Since it's positive, that means that the right end goes up. So this side goes up. Since the ends go the same, that means that the left goes up, and we don't know what's going on in the middle. Okay, so that's how we determine the end behavior of our graph. We look at the degree to see if the ends are going the same or opposite, and then we look at the leading coefficient to tell us what the right side is doing. Okay. The next thing we want to look at is identifying our zeros. Okay, our zeros give us our x-intercepts. Now, when we deal with graphing polynomials, they say several different things. They say find the roots, find the zeros, find the x-intercepts. These are all the same thing. Okay, so what we're doing is we're really just setting y equal to 0 and solving for this. And we can use factoring, we can use quadratic formula, we can use grouping, okay, whatever we need to do. In this case, I can factor this, right? I can factor using sum product. If I use the sum product chart, okay, I need something that sums to -2, that multiplies to -8, which in this case would be -4 and +2. And since my leading coefficient is a 1, I can use my shortcut. So that tells me that this factors into x minus 4 times x plus 2. So I'm going to go ahead and set that equal to 0 so that I can solve each of these. So this means that x minus 4 equals 0 or x plus 2 equals 0. When I solve, I move my 4 to the other side, which says x is 4 or x is -2. Okay, so that means that the zeros of this polynomial are -2 and 4. Okay, so we already know how to solve by factoring. The only other thing I want to go over is what we call synonymous statements. Okay, synonymous is, think like synonym. Okay, it just means they mean the same thing. So here it says if x equals a is a solution, okay, which is what we got. We got x equals 4, x equals -2. This means that x minus a is a factor. So notice up here, if I look at what the second bullet's saying, they're saying that if x equals 4 is an answer, then that means x minus 4 was a factor, which is true. Okay, all I do is change the sign because it would be like moving it back over across the equal sign. So if you get an answer for x, that means if you were to subtract that answer, then that would be a factor of this polynomial. Okay. The next thing it says is that f of a is 0. So that means if I were to plug in f of 4, I would get 0. If I were to plug in f of negative 2, I would get 0. Okay? If it's a solution, if it's a root, if it's a factor, all these things mean the same thing. So if x equals 4 and x equals negative 2 are my zeros, that means if I plug them back into the function, I would get 0. Okay? And then the last one is that these two solutions I got, since we're calling them zeros, that actually means that they are x-intercepts of this polynomial. Okay? So that means that negative 2, 0, and 4, 0 are x-intercepts. Okay? So all these statements mean the same thing. So if you get stuck on something where they ask for a factor, or they ask for an intercept, or they ask for a root, or they ask for a solution, okay, it's all the same thing. It's just in how they want it entered. If they want it entered as an x-intercept, it needs to be an ordered pair. If they're asking for one of the factors, it needs to be in a quantity. Okay, if they're asking for a solution, then you just say the zeros, or my solution is x equal whatever the actual number is. Okay? Okay. So we know how to find the zeros. Let's look at a couple more just finding zeros. Okay, notice to find the zeros, we just set it equal to 0. And this one I have 4 terms. My method for 4 terms is grouping. So out of the first 2, I can pull out an x squared, which leaves me with x minus 2. The second pairing, I can pull out a negative 9, which leaves me with x minus 2. So I have x minus 2. When I take that out of both terms, I'm left with x squared minus 9. And notice this one is a difference of squares, right? So this x squared minus 9, I can factor that on down into x plus 3 and x minus 3. Okay. Once I have each one completely factored, then I just set each one equal to 0 and solve. Okay. So here when I move my 2 over, I get x equals 2. When I move my 3 over, I get x equals negative 3. When I move my negative 3 over, I get positive 3. So that means that the zeros of this h of x function are negative 3, 2, and 3. Okay, those are also my x-intercepts. If it asks for them as x-intercepts, make sure you enter them as ordered pairs. Okay, let's look at another one. Now this one's a little bit different. Notice this one's already factored for us. So if this one's already factored for us, that's the best case scenario. I just have to make sure each factor is completely factored, and then I set each factor equal to 0. Here notice x plus 2 can't be factored any further. X minus 3 can't be factored any further. So I'm just going to set each of these equal to 0. Now notice my 5 here doesn't have a variable. So I don't have to set 5 equal to 0 because, well, 5 doesn't equal 0. So I'm just going to ignore that one. But I am going to set x plus 2 cubed equal to 0 and x minus 3 equal to 0. Now on this first one, to get rid of a cube, I just take the cubed root. Okay. And the cube root of 0 is just 0. So I'm left with x plus 2 equals 0. And then I can go ahead and subtract my 2 over, which gives me x is equal to negative 2. On the second one, when I move my negative 3 over, it becomes positive 3. So here, the zeros of my f of x function are negative 2, oops, I don't know why I have to parentheses, are negative 2 and 3. Okay, all right, so there's one at the bottom of the page for y'all to do. I'll give you just a minute, and then we'll go over it, okay? All right, so on this practice problem, notice it's already semi-factored for you, but the first factor is still able to be factored further. So I can do some product with that. I need something that multiplies to negative 35, that combines to negative 2, which would be negative 7 and positive 5. Since my leading coefficient is 1, I know those are my factors. So that piece factors into x minus 7 times x plus 5. And then I have another quantity, x minus 7, that was already factored out. So now all I do is set each factor equal to 0. And notice here, since my last factor and my first factor are the same, that last one is just a repeat. So I'm not going to resolve it because I'll get a variable, I'll get an answer that I already have. Okay, so I only solve the first 2, so I don't have repeats, which means my zeros would be negative 5 and 7. Now, speaking of having a repeat 0, depending on how many times we get a 0, it tells us a specific behavior of our graph. Okay, and instead of calling it repeats, we call it multiplicity. So multiplicity is what we're going to go over on the next page. We're still needing to find the zeros, but now we want to know how many copies of each zero we have. Okay, determining the multiplicity of roots. So if this is our factor here, x minus c raised to the k power, okay, so that would be something like x minus 7 squared, like we would have had in that last problem. We had 2 copies of this factor, right? Okay, all right, if x minus c to the k power is a factor of f, then if the multiplicity of the root is even, meaning k is even. If k is even, then the graph touches at the point C0. So whatever factor we get from solving, so like this one, when I solve, I would get x equals 7. That means that this picture of this graph would touch at 7, 0. So at this x-intercept, because this is an even power or an even multiplicity, then the graph only touches at that x-intercept. It doesn't actually cross the x-axis. Okay? So if k happens to be odd, so if k is odd, then the graph, crosses at C0. Okay? So this would be like if I had something like x minus 7 to the 5th power or something, okay? If that multiplicity or the number of those factors you have, the exponent on your factor is even, then your graph touches at the x-intercept you get from that factor. If the multiplicity or the little exponent is odd, then your graph crosses the x-axis at that given x-intercept that you get from that factor. Okay, all right, so let's go ahead and look at some. We're going to identify the multiplicity and then determine at which x-intercepts it crosses and touches. So notice here, I have a negative that's just out front. Okay, remember, negatives are telling me if it's pointing up or down and what the end behavior is. So I'm just going to look at this x squared. Because it has a square on it, and this is the whole factor, I know that because 2 is even, that this is only going to touch. Okay. Notice my next factor, I have a power of 3. Okay, so this one is going to cross because it has an odd multiplicity. And then my last one doesn't have anything written up there. So it's like to the 1st power, 1 is odd, so this one is also going to cross. So I'm going to go ahead and solve each of these so that I know the x-intercept. So if I do negative x squared equals 0, x minus 9 equals 0, and x plus 12 equals 0. Notice on this one, even though it's cubed, I didn't write x minus 9 cubed, because the first thing I would do is take the cube root, and when I take the cube root of 0, I still end up with 0. So when you're solving these factors, you really don't have to worry about the power on it when you're just trying to find the zeros. Okay? So notice on this first one, x squared, here, you know, again, I could divide off the negative 1, which gives me x squared equals 0, and then take the square root of both sides. And when I do plus or minus 0, here I just get 0. Okay, so this means this x-intercept is going to be 0, 0. And remember, it had multiplicity 2 because it was squared. Okay. So since it has multiplicity 2, just like above here, I wrote that it touches. So I'm going to go ahead and over here it says touches at x equal. I'm going to go ahead and write the ordered pair, okay, because we want to write it as an x-intercept. So instead of x equals, I'm just putting the actual x-intercept. When I solve the second one, I move my 9 over, which gives me x equals 9. And remember, this one had multiplicity 3, right? So as an x-intercept, this would be 9, 0. And because it had multiplicity 3, we know that it crosses at 9, 0. So I'm going to put 9, 0 over here under crosses. And then my last one, when I solve, I'm going to move 12 to the other side. So I have x is equal to negative 12. So my x-intercept from that solution is negative 12, 0. And here, I didn't have any multiplicity, right? I have multiplicity 1 because I only have 1 copy. So if I have 1 copy, that means it also crosses at that x-intercept. So it crosses at negative 12, 0. Okay? So we still solve each factor just like we did before to find the zeros, but then once we have the zeros, we write them as ordered pairs because they represent x-intercepts, and based on how many copies of that factor we have, that tells us the multiplicity, which in turn tells us whether it touches or crosses at that point. Okay, let me look at another one. On this next one, first thing I want to do is factor it, okay, because we're looking at multiplicity of factors, not degree. So first thing I want to do is factor. This is a difference of squares, so this factors into x squared minus 4 times x squared plus 4. Okay. And then this first quantity is another difference of squares. It factors into x plus 2 times x minus 2. Now, we don't have any rules for, excuse me, a sum of squares. So I'm just going to leave it like that and go ahead and set each one equal to 0 so I can find my roots. So x plus 2 equals 0, x minus 2 equals 0, x squared plus 4 equals 0. Okay. When I solve the first one, I get x equals negative 2. And notice up here, it was to the first power. I only have one copy of that factor. So this has multiplicity 1, which means that it crosses at that x-intercept, which since we got x equals negative 2 would be negative 2, 0. When I solve the next one, same thing. When I move the 2 over, I get x equals positive 2. I look at the factor that came from, and notice up here, x minus 2, I only had one copy of that factor. So this one has multiplicity 1. Since 1 is odd, that means it crosses the x-axis at this intercept, which would be 2, 0. So I'm going to go ahead and put those up here on cross. I have negative 2, 0 and 2, 0. And when I solve my last one, I subtract 4, which gives me x squared equals negative 4. I take the square root of both sides, so plus or minus the square root of negative 4, and notice I have a problem. I get x equals plus or minus 2i. Now when we start working these where we find the zeros, we can enter imaginary zeros, but we can't have imaginary x-intercepts, okay, because we're not going to graph anything other than real numbers in this class. So here, I'm just going to go ahead and say, cannot have complex, or in other words, imaginary intercepts. Okay, so because negative 2i and positive 2i are numbers we can't graph, we don't care about their multiplicity because we can't graph them. We don't know if it touches or crosses because we can't put them on our rectangular coordinate system. So I just ignore those two, which means that I don't have any that touch. So I'm just going to write none. Okay. Okay, so there's one on the next page for y'all to try. Go ahead and factor it as much as possible, and then based on its multiplicity, write out whether it touches or crosses at the given x-intercepts. I'll give y'all just a minute to work on that one, and then we'll go over it, okay? All right, so on this practice problem, notice it was already factored for you, so I gave you an easier one than I thought. All we have to do is identify the zero that correlates to each factor. So I set each one equal to 0, and I just ignore their multiplicity and solve for what's inside the parentheses. So I get x equals 0, I get x minus 1 equals 0, x minus 2 equals 0, and 2x plus 1 equals 0. When I solve all four of those, I get x equals 0, x equals 1, x equals 2, and x equals negative 1/2. I went ahead and wrote them as ordered pairs to represent x-intercepts. And then I look at their multiplicity, which I wrote above the function. So x to the 5th, 5 is odd, so it crosses at that x-intercept. X minus 1 has an exponent of a 1 here, right? Because there's nothing written there. 1 is odd, so it crosses. The third factor is squared. Since squaring is even, then we know it touches at that given x-intercept, which is 2, 0. And then the last one crosses because it has multiplicity 3. Okay, so I'm just going to write down here, this has multiplicity 5, this one has multiplicity 1, this one has multiplicity 2, and this last one has multiplicity 3. On your homework, it will ask you to enter the 0 and its multiplicity, so make sure you remember what that means, okay? Okay, so we're getting closer. We know how to find the zeros, and now we know how to determine the multiplicity or the behavior at the zeros. We also know how to find the end behavior. Now the last thing we have to do is determining what's happening in between our zeros. Okay, because all we've done so far is whether it touches or crosses at each one and what the ends are doing, but we don't know what's going on in between those intervals. So what we're going to go ahead and do is we're going to pick test points from each interval and just plug in the test point. If the test point yields a positive value, then we know it's above the x-axis. Okay? If I pick a test point from an interval and it ends up negative, then I know all the values in that interval are going to be below the x value. So here it says use the previous practice problem. So I'm going to go ahead and put what our last problem was down here. This one that y'all just did on the top of the page, which is f of x is equal to x to the fifth times x minus 1 times x minus 2 squared times 2x plus 1 cubed. Okay, and I'm going to go ahead and write down here, because we already found our zeros. Our zeros were -1/2, 0, 1, and 2. So really what we're trying to determine is what's happening on the graph between all of these numbers. So I'm going to go ahead and draw a graph just to help out here. Pretend it's straight. Okay. So we have a 0 at -1/2, we have a 0 at 0, a 0 at 1, and a 0 at 2. So notice here on this first little box, it says, my first row, it says interval. So I want to test this interval right here, okay, to see what's happening in it. So a representation of that interval is everything to the left up to -1/2. So this would be from -infinity up to my first 0, which is -1/2. Then my next interval would be between -1/2 and 0. So I'm going to say -1/2 to 0, and then 0 to 1, and then 1 to 2, and then 2 to infinity. So I'm just testing every interval between every 0. Okay, so I'm going to go ahead and scroll down so we can do our testing, and then I'll scroll back up and we'll talk about it here in a second. So if I want to pick a value that falls into this interval, and I'm going to make this a little bit smaller. All right, I want to pick a number that falls in between -infinity and -1/2. So some number that's to the left of -1/2, I'm just going to pick -1. Now notice it says, what's my function value? So what that is asking is if I plug -1 into this function, what am I going to get? So down here, I'm going to go ahead and plug it in. F of -1 is equal to, I have x to the fifth, I'm just plugging it up here where I wrote it in, x to the fifth, so -1 to the fifth, times, now notice my next quantity is x minus 1. So if I do -1 minus 1, I get -2. If I plug -1 into this next quantity, -1 minus 2 gives me -3 squared. And then if I plug -1 into this last quantity, 2 times -1 is -2, plus 1 is -1 cubed. Okay, and then I just multiply those all together, which we can do in our calculator, which should give me -18. So my y value at -1 is -18, and here it says the sign of that y value. So here, since I ended up with a negative, what that means is that all the points in this interval fall below the x-axis. So I'm just going to write here, below x-axis. Okay. Then I look at my next interval. I need to pick a number that's between -1/2 and 0. So something that falls in this interval, something between -1/2 and 0, I'm going to pick -1/4. But to plug it in, just because we don't actually care what we're doing with these values, we just want to know if it's positive or negative, I'm going to use it in decimal form. So -0.25 is the same as -1/4, right? So I'm going to go ahead and do f of -0.25. When I plug it into my function, which I have written up here at the top, I get -0.25 to the fifth times, when I plug -1/4 into my second quantity, I do x minus 1. So -0.25 minus 1 is -1.25. When I plug it into my third quantity, negative 0.25 minus 2 is negative 2.25, and that quantity is squared, times my last quantity, which here says to do 2x plus 1. So 2 times negative 0.25 gives me negative 0.5 plus 1, which is positive 0.5, and I'm cubing that. Okay. Then again, I can just plug this into my calculator, which gives me something horrid like 0.0007 and some more stuff. Okay. So I end up with positive 0.0007 and some more stuff, which means that this is a positive interval, which means that this is above the x-axis. Okay. So every number between negative 1/2 and 0, when I plug it in, I'm going to get a y value that's above the x-axis, or a positive y value. Okay. All right, let's test our next interval, which is from 0 to 1. A number between 0 and 1, I'm just going to pick a half, and I'm going to write it as 0.5. So I'm going to plug in f of 0.5. Excuse me. When I plug 0.5 into my function, I'm going to get 0.5 to the 5th times 0.5 minus 1, which is negative 0.5, times 0.5 minus 2, which is negative 1.5, and that one's squared, times 2 times 0.5 is 1, plus 1 is 2, and that one is cubed. Okay. When I plug this into my calculator, excuse me, I end up with negative 0.28125. Okay. Again, we can round or whatever, because we're just trying to figure out if they're positive or negative intervals. So here I get negative 0.28125, which means this is a negative interval. If it's a negative interval, that means all my y values are below the x-axis. Okay, I have 2 more intervals. I'm going to plug in 1.5 here because that's between 1 and 2. And then for something bigger than 2, I'm going to plug in 3. Okay, so you get the gist of it. So here if I plug in f of 1.5, I'm going to get 1.5 to the 5th times 1.5 minus 1 is 0.5 times 1.5 minus 2 is negative 0.5. That one's squared. And then 2 times 1.5 is 3, plus 1 is 4 cubed. Okay. And if I multiply all those together, I get 60.75. 60.75, which is a positive number, which means that all of my y values for this interval of x's are going to be above the x-axis. Okay. Let's do one more. When I plug in f of 3, I get 3 to the 5th times 3 minus 1, which is 2, times 3 minus 2, which is 1, squared, times 3 times 2, which is 6, plus 1, which is 7, to the 3rd. And when I multiply all that out, I end up with this huge number, 166,698. 166,698, which is positive. Excuse me, which means that all my x values here are above the x-axis. Okay, so let me tell you why we care. The whole idea is that if we want to graph this, I want to be able to draw a really nice picture, right? So here, remember we looked at the top of this page, we figured out if they touched or crossed. And notice there's only one that touched, and that was at 2. That was at this one, right? Okay, so I'm going to go down here and just look at my below, above, below, above, above. I'm going to start out below my x-axis, and then at negative 1/2, remember it crosses, so I'm going to come up and have positive values. And then at 0, it crosses, so I'm going to cross and come down here and have negative values because it's below the x-axis. And then notice at 1, it crosses again, and I have positive because it's above the x-axis. And then when I get to 2, remember it only touches. So notice the interval from 1 to 2 I got above the x-axis, and from 2 on I get above the x-axis. So that means it does something like this. So it just bounces at 2 and stays on the same side. Okay. So my function looks something like this. Now I don't know how high or how low it goes in between the zeros. But I can just use my test values to get a good picture. Okay, so what we're going to do now is we're going to put all of this together and try to graph these. Okay, the only other thing we have to go over is finding the y-intercept, which we already know how to find the y-intercept. We just plug 0 in for x, and we write it as an ordered pair. So I'm going to go ahead and do just a couple of finding the y-intercept, and then we'll put everything together. Okay, so y-intercept, remember h of x, this is the same as y equals, and to find the y-intercept, we put 0 in for x. So I have 0 cubed minus 2 times 0 squared minus 9 times 0 plus 18. Notice all these terms that have 0 just go to 0. So I get y equals 18. So my y-intercept here would be 0, 18. Okay, let's get another one. Same thing here, f of x is the same as y. I put 0 in for x to figure out my y-intercept, and then I just simplify. So I get 5 times 2 cubed times negative 3, which is 5 times 8 times negative 3. 5 times 8 is 40, times negative 3 gives me negative 120. So that means my y-intercept here is 0, negative 120. Okay, so we know how to find the end behavior. Here, I'll go over it. It's all written at the bottom of the page. It says we put it all together. Okay, so our steps for graphing a polynomial equation. First thing we do is we look at the degree of the polynomial. That tells us if our ends are the same or going opposite directions. Then I look at the leading coefficient, which tells me what the right side's doing. So either the right side's going up if it's a positive coefficient, or the right side's going down if it's a negative coefficient. Okay. Then we find all the zeros by factoring or using quadratic formula. Once we've found all the zeros, we find their multiplicity. Once we know their multiplicity, we know whether or not they touch or they cross at those given zeros. And then we plug in test points like we did on the last page to determine if our values in each interval are going to be above the x-axis or if they're going to be below the x-axis. Okay. Then we find our y-intercept, just always have a good point. And then using all of that, we're going to sketch the general shape of the function. Again, we're not looking for a super duper identical to the correct function picture, but you should have the general shape. You should know when it goes up, when it goes down, that kind of thing. Okay. All right, so let's go ahead and look at one. Here we have this function. F of x is equal to negative x cubed times 2x minus 3. So notice this one's already factored for us, which is good. Now, because it's factored, that makes it a little bit harder to see the degree. Remember, we look at the degree of the function when it's all multiplied out. So if I were to distribute this in, which I'm not actually going to do, but if I were to do it, notice when I do negative x cubed times 2x, I would get negative 2x to the fourth, right? So my highest degree here is actually going to be a 4. So I'm going to go ahead and come down here and say this is a degree 4 polynomial. If it's degree 4, okay, that means it is an even degree, which means the ends go the same direction. So they either both go up or they both go down. So I look at my leading coefficient. My leading coefficient in this case, if I just distribute this, right, that's going to give me my highest power term. My leading coefficient, negative x cubed times 2x, is going to give me negative 2x to the fourth. So my leading coefficient is actually a negative 2. And I don't necessarily care what the number is, excuse me, but we do need to know if it's positive or negative. So here, since we got a negative 2, that means that the right end goes down. Right side down. Okay. So the right side's going down, the ends are going the same, which means the left side's going down, and we don't really know what's happening here. Okay, so we know our picture should be some type of parabola-esque looking picture pointing down. So now let's go ahead and find our zeros. To find our zeros, we just factor and set each one equal to 0. Now here it's already factored for us, so we just need to set each one equal to 0. So negative x cubed equals 0, or 2x minus 3 equals 0. I divide off the negative, which gives me negative x cubed equals 0. When I take the cube root, I get x equals 0. Right? Here when I solve, I move my 3 over, which gives me 2x equals 3. Then I divide my 2 off. So I get x equals 3 halves. So I want to go ahead and state their multiplicity. This x equals 0, notice it was cubed. So this one has multiplicity 3, which means that it crosses at that x-intercept, which would be 0, 0. Okay. My next one has multiplicity 1, right? Because I only had one copy of that factor that it came from, which means that it also crosses, okay, at the x-intercept 3 halves 0. Okay. So I want to go ahead and put those values on here. And for my x-axis, I'm going to go ahead and scale my graph a little bit larger. Okay. I'm going to go by halves on the x-axis. This is 1 half. This would be 1. Whoops, that didn't work out right. This would be 1. This would be 2. This would be 3. This would be 4. Okay. This would be -1. -2. Okay, so only for the x's I'm going to change. I'm going to leave the y's the same. So we know that this crosses at 0, 0, so I'm going to go ahead and put that point on here. And it also crosses at 3 halves. Now 3 halves is like 1.5, or it is 1.5. Okay, so I have my 2 points, and I know from here both ends are going down. Okay, so I really just need to see what's happening in the middle. But just to be efficient, I'm going to go ahead and test each interval. Okay, so on my graph, my zeros, I have from -infinity up to 0. And then I have from 0 to 3 halves. And then I have from 3 halves on out to infinity. Okay, so these are the 3 intervals that I get between my zeros and on either side. So I'm going to test these values. So something smaller than 0, I'm going to pick -1. Something between 0 and 3 halves, I'm going to pick 1. And something larger than 3 halves, I'm going to pick 2. Okay. So I'm going to go ahead and plug these in. If I plug in f of, and I'm going to go ahead and write f of x here. It's -x cubed times 2x minus 3. So if I do f of -1, I have a negative that's already there, and then I'm doing -1 cubed times 2 times -1 is -2, minus 3 is -5. So notice if I simplify that out, what I end up with is -5. Because my -1 cubed stays negative, then the negative outside of that makes it positive, times -5 gives me -5. Which means this is a negative interval, which means that the points are all going to be below the x-axis. Right? Which we knew, because notice we went ahead and kind of drew the little arrow there to the left of 0, which we know it's going down because of our end behavior test. So let's now test the interval between 0 and 3 halves. So we're going to plug in f of 1. So I get +1 cubed times, if I plug +1 into the second factor, 2 times 1 is 2, minus 3 is -1. Okay, -1 cubed is 1. There's a negative weighting outside, so -1 times -1 gives me +1. Excuse me. So when I plug in +1, that gives me a positive value, which means that my y values for that interval between 0 and 3 halves are going to be above the x-axis. Okay, and then the last value I need to plug in is 2. 2 is my representative from the 3 halves to infinity interval. So if I plug in 2, I have -2 cubed times, if I plug 2 into the second one, 2 times 2 is 4, minus 3, which is 1. So 2 cubed is 8, then there's that negative weighting out front, so I get -8. Which means this is a negative interval, which means that my y values are going to be below the x-axis. Now sometimes we don't know how far down it goes, or you get something like -6,000, okay, which isn't on our graph. There we can just kind of guesstimate the shape of our curve, but here since I got y values that are on my 12 by 12 grid, I got -5, 1, and 8, I'm going to go ahead and actually just put on those values. So at -1, I'm down at -5, 2, 3, 4, 5, oops. 1, 2, 3, 4, 5, which is here. Okay, so I'm going to erase this arrow. I'll redraw it in a minute. At +1, I'm up at 1. and at 2, I'm down at -8. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is going to look something like this. Okay, now this may actually go up higher in here or something like that. I don't really know. I'm not going to plug in every point in between those two x-intercepts, but I do want to just make sure I have the general shape. Okay, so notice, just like we said before, it's crossing at 0, 0, it's crossing at 3/2. The end behavior said both sides go down. They do go down, and they're both going the same direction. Okay, let's look at another one. All right, on this next one, notice it's not factored for us. So we need to factor it. It's got 4 terms, so I'm going to factor by grouping. But before I do that, I want to go ahead and identify my degree and my leading coefficient. So here, since it's already multiplied out, I can see that my degree is 3. Since it's degree 3, I know that the ends are going opposite directions. Okay, and then I look at my leading coefficient, which in this case is +2. Since it's +2, my little dots are turning together. Since my leading coefficient is 2, that means that the right end goes up. Right end up, because I have a positive leading coefficient. Now I want to go ahead and find my zeros. To find my zeros, I'm going to factor, so 2x cubed plus x squared minus 8x minus 4 equals 0. So I'm going to group. Out of the first pairing, I can take out an x squared, which leaves me with 2x plus 1. And I can take out a -4 out of my second pairing, which leaves me with 2x plus 1. Now I'm going to take out that 2x plus 1, which is going to leave me with x squared minus 4. Okay, and then this one here is a difference of squares. So if it's a difference of squares, I can factor it into x plus 2 times x minus 2. And then I just solve each one. So this means that 2x plus 1 equals 0, x plus 2 equals 0, or x minus 2 equals 0. When I solve the first one, I move my 1 to the other side, so I get 2x equals -1. Divide the 2 off, which gives me x equals -1/2. On the next one, when I move my 2 over, I get -2. And on the last one, when I move my -2 over, I get +2. Okay, so if you look right above where I work this out, notice every single factored quantity here, I only have one of that factor. I don't have any multiplicity bigger than 1. So since this one is multiplicity 1, then we know it crosses at the x-intercept -1/2, 0. Same thing on the next one. The next one has multiplicity 1, so we know that it crosses at -2, 0. And my last one also only had one copy of that factor, so it's also multiplicity 1, which means that it crosses at its x-intercept, which would be +2, 0. Okay, so this one I'm going to scale it like I did the last one. Excuse me. I'm going to go by halves since we have a half here. So I'm going to call this 1, this is 2, this is 3, this is 4. And over here I have -1, -2, -3, and that's probably far enough. Okay, so my x-intercepts are at -1/2, which is here, at -2, which is here, and +2, which is here. Okay. Now we know that our end behavior, right? Our ends are going opposite directions, and the right end's up. So we know this one goes up, and we know from here this one goes down. But we need to figure out what's going on in between with our touching and crossing. Okay. So we're going to go ahead and write out the intervals. Okay. So my first interval is going to be from -∞ up to my first 0, which is -2. And then from -2 to my next 0, which is at -1/2. Then -1/2 to my next 0, which is at +2. And then from +2 on out to infinity. Okay. So I'm going to pick a test value in each of these intervals. From -∞ to -2, I'm just going to plug in -3. Between -2 and -1/2, I'm going to plug in 0. Excuse me. Sorry, not 0. 0 isn't between there. We'll plug in -1. In the next interval, I have a negative to a positive, so I can plug 0 in here. And then from 2 to infinity, I'll pick 3. Okay. So let's go ahead and plug these in. If I plug in f of negative 3, and notice, I will tell you on this one, because if you look at your original, it is not factored. When you plug in these test values, you can plug it into the original, or you can plug it into the factored version. I like to plug it into the factored version, so I'm going to go ahead and write that over here. F of x is the same as 2x plus 1 times x plus 2 times x minus 2. Okay, so when I plug in this first one, f of negative 3, when I plug in negative 3, 2 times negative 3 is negative 6, plus 1 is negative 5. Negative 3 plus 2 is negative 1, and negative 3 minus 2 is negative 5. So I multiply these together, I get negative 25, which means that my y values from this interval should all be negative, which means that they are, below the x-axis. Okay. Then I want to look at my next test point, which is negative 1. When I plug in f of negative 1, 2 times negative 1 is negative 2 plus 1 is negative 1. Negative 1 plus 2 is positive 1. And negative 1 minus 2 is negative 3. So when I multiply those together, I get positive 3. Which means that my y values for that interval are going to be positive, which means that they are above the x-axis. Okay. Then I want to do a test point between negative 1/2 to 2, which I pick 0. When I plug 0 in, 2 times 0 is 0 plus 1 is 1. 0 plus 2 is 2. And 0 minus 2 is negative 2, which gives me negative 4. Which means that this is a negative interval, which means that all my y values should be below the x-axis. Okay. And then my last test point is 3. When I plug in 3, I get 2 times 3, which is 6, plus 1, which is 7. 3 plus 2, which is 5. And 3 minus 2, which is 1. So when I multiply all these together, I get 35, which means that this interval is a positive interval, which means all the y values should be above the x-axis. Okay. So now that I know that, let's go ahead and plug these numbers in. Now the last two, when I plugged in negative 3 and got negative 25, that's off my graph. And when I plugged in positive 3, I got 35, that's off my graph. But I should be able to plug in the other ones, or at least do a general assumption of where they would be. Oh, and I forgot to do my y-intercept. Let me go ahead and do this. When I do my y-intercept, I plug 0 in for x. Oh, I did do that. That's one of the points I plugged in. Oh well. If we plug it into our original, okay, let me scroll up. Then I have 2 times 0 cubed plus 0 squared minus 8 times 0 minus 4. Okay, which just gives me y equals negative 4, which is the point 0, negative 4. So I'm going to go ahead and put that on here. 1, 2, 3, 4. Here's my y-intercept. Okay, again, I scaled my x's a little larger. My y's I'm just going to leave the same. So let's go ahead and plot the numbers we can here, and then we'll make a good shape. I can't plug in negative 3 because it's off the graph, which I can adjust this arrow because I know at negative 3 it should still be going down. At negative 1, I know I'm up at positive 3, 2, 3, which is here. And then at negative 4, I'm sorry, at 0, I'm at negative 4. I already have that one. That's my y-intercept. And then my last point that I plugged in was 3. So at positive 3, I am up at positive 35. So I can't plug that one in either. But I know at positive 3, that should be shooting way up. So let's go ahead and adjust. Let me take these arrows off and redraw it. So at negative 3, it's shooting way down. So I'm just going to go ahead and start like this. It comes up, it crosses, goes up to that high point that we found, comes back down, crosses again at negative 1/2, goes through my y-intercept, and it may go further down, I don't know. And then it comes back up and crosses again at 2, and it should keep going up. Okay. Are we kind of okay with that? As long as you have this general shape, I'm not going to count off points for how far down you go here, okay? But I do want to make sure you have that y-intercept point on there, okay? All right, so on the next 3 pages, there's 3 for y'all to try. I do want to point out, depending on when you printed out your lecture guides, I made a change to problem number 2. Well, problem number 1, there was 1 too many columns. So if you have 4 columns over here, you can just mark out that 4th one. Okay, I already fixed it on mine, but if you happen to have 4 columns, you don't need that 4th one. On number 2, I changed the problem to x to the 4th minus 9x squared. So if you still have the old problem, go ahead and mark it out and make sure you have this one written in. I'll give you a little while to work on these 3 and then we'll go over them. Okay? Okay. So on the first practice problem, first thing we do is look for the degree. Now the degree on this one's a little hard to find because it's not multiplied out. So what I did up here is, hold on, let me get myself a pointer. So what I did up here is I rewrote the problem, and on the second factor I wrote the x first. So I have x plus 4 minus x plus 2 times x minus 2. So to get our leading coefficient and our degree, we would look for the highest order term once this is all distributed out, which is what I get when I multiply my x terms together. So here when I do x times negative x, that's negative x squared times another x is going to give me negative x cubed and some other stuff. So right here I can see that my degree is going to be 3 and my leading coefficient is going to be negative 1. Okay, degree 3 means my ends go opposite. Leading coefficient of negative 1 means the right end goes down. So I solve to get my zeros. Notice when I solve the second 2, I get x equals 2 on both, which means that that 0 is repeated, which means it has multiplicity 2, so it touches at the x-intercept 2, 0. Okay, and then I get negative 4 for the other one. I only had 1 copy of it, so it crosses. So I go ahead, and I found my y-intercept by plugging 0 into my function, which gave me negative 16. And then I just want to test the intervals just to make sure. So notice down here I have an interval from negative infinity to negative 4, from negative 4 to 2, and from 2 to infinity. So I chose a number in each interval. Here I chose negative 5, 0, and 3. If you chose different numbers, that's fine, as long as they're numbers that actually are in that interval. Okay, so notice in my first interval I get a positive, and then my next 2 are negative. So when I go up here to draw this, okay, notice I'm starting up here positive, it crosses at negative 4, and then I go down into negative territory, hit my y-intercept. When I come up to 2, remember it only touches, so I'm going back down negative in that direction. Okay, so that's the first one. Let's look at the second one. Same idea. First thing I want to do is identify the degree. This one's already multiplied out, so it's a degree 4, and my leading coefficient is a 1. So degree 4 means the ends go the same direction, and my leading coefficient of 1 tells me the right side goes up. So I know it should be making some shape kind of like this. I go ahead and factor it. When I factor it, I can factor it all the way down to x squared times x plus 3 times x minus 3. And this is the form I'm going to use to plug in my values over here, okay, if you're looking at my work. I didn't plug them into the original, I plugged them into the factored form. Doesn't matter either way. When I solve each one, I get 0, negative 3, positive 3. The first one has multiplicity 2, which means it touches at 0. And the other 2 have multiplicity 1, which means they cross at negative 3 and positive 3. Okay, make sure you write those as order pairs. Then to find my y-intercept, I plug 0 in for x, which gives me 0. So my y-intercept is the origin. Okay, so I want to go ahead and write out my intervals. So I have negative infinity up to my first 0, which is negative 3. From negative 3 is 0, and from 0 to 3, and then from 3 to infinity. So that's what I did down here. Wrote out my intervals. I picked a number in each interval, plugged it in, which tells me that I get a positive interval, a negative, and a positive. So notice when I go up here to graph this, my first piece of my graph, my y values are positive. They're above the x-axis. Then I cross at negative 3 and they become negative. Okay, and I went ahead and plotted these 2 points that I got from my test points. Okay, so they're negative. I come up, I hit my origin, which remember it only touches because that one had multiplicity 2. So it goes back down negative, and then again comes up to positive 3, and then crosses, and my y's become positive. Okay, let's look at the last one. The last one was kind of ugly, right? I can see that it's a degree 7, which means my ends go opposite directions. Since my leading coefficient is 2, that means the right side goes up. So if the right side's going up, my picture should look something like this. Okay, I don't really know what's going on in the middle, so I go ahead and factor. Now, I took out my greatest common factor first. If you factored by grouping, that's fine. Make sure all of your factors are completely factored before you start finding your x-intercepts. Okay, so I took out 2x to the 4th first, and then with what was left over, I went ahead and did grouping. Okay, when I get it all factored down, I end up with zeros of 0, 3, negative 2, and 2. At 0, notice here I had an x to the 4th. So that one has multiplicity 4. So it's going to touch at the origin. All my other zeros, I only had multiplicity 1, so they're all going to cross at 3, negative 2, and positive 2. So I went down here and I wrote out all my intervals. So I have an interval from negative infinity to negative 2, negative 2 to 0, 0 to 2, 2 to 3, and 3 to infinity. I pick a point from each interval to see whether my y's will be above the x-axis or below the x-axis at that point. Okay, with these values, along with me knowing that it touches or crosses and what my end behavior is, I should get a decent picture. Okay, now when I plugged in some of these values, I got some horrible values that are off the graph, right? Like when I plugged in negative 3, I got negative 4,000 something. When I plugged in 2.5 and 4, I got numbers that are way off the graph. Okay, so that tells me that those should shoot really far up and really far down. So make sure, even though we're just doing a sketch, you go ahead and make them shoot high and low if you know they go off the graph. Okay, so when I plotted these, notice it started off negative because of our end behavior. We know it starts going down to negative infinity. Okay, I come up, we know it crosses at negative 2, and it shoots all the way up to this point that I plugged in, which was 24. Comes down, only touches at my origin, because remember there was a multiplicity of 4 there. Okay, and then it's going to shoot up a little bit. It might actually shoot higher than this, but that's the point I plugged in, so I stopped there. It's going to come back down, cross at 2. Okay, and then this is where I got one of those values that went down to like negative 89 or something. So I went ahead and took it all the way to the bottom of the graph before I came back up. And then it crosses again at positive 3, and then it shoots on up to some crazy high number. So I just went ahead and stopped my arrow there. Okay, so you should be able to get this general shape. I'm looking for the general shape to make sure you have all the x-intercepts correct, to make sure you have the y-intercept correct, and that your end behavior is correct. Okay.
That is the end of 3.1, so you should now be able to complete the 3.1 assignment in My Math Lab, as well as the 3.1 worksheet. Okay? Let me know if you have any questions.